So today I finished this end-to-end pipeline until almost until submission. So that's why 99%, a tiny bit is still remaining. I'll get to it. How? So looking at the code, reducing of error and doing all the gradient descent, I did that. And the remaining part was experimenting with the model. And let's check the code, which is very easy to read code I have written just for this. So the first section was data set. Okay, read the data set from images which are in the folder. So I have put them into a format which is easy to read. You can find the dataset link on my GitHub repository if you want to do Kaggle dog breed classification. So simple, take the training data set, convert into 224, comma 224, and you see almost every relevant command line argument needed for this function from TensorFlow has been included. Okay. So get 120 classes and around 1000 files for validation, 9000 for training, and around maybe 10,000 for final testing we need. Okay. So for the model part, okay, first is model from scratch. The neural network architecture is very simple, three-layer architecture. First is input layer, then hidden layer, and then we have final output layer. 240 neurons in the hidden and 120 here. So in the code was written in this format by overriding keras.model and converting the model into separate things, initialization and the forward pass. By doing this, it allows us to debug better. So I did that, wrote the code in this way and removed the bugs which I removed yesterday. And in simple one line thing, it starts giving us accurate answers. So here in this, it gives you around just 0.6% accuracy if you do this. Because the neural network is actually pretty small, the 120 different kinds of dogs we have. So the network we are going to need is going to be complex. So one way to do it is, make it complex, train, make the model complex, figure out better ways to do it. And it is time consuming. And then there is another way, which is the default way nowadays. The common data problems, whether it is in computer vision or natural language processing, there are few data sets which are so common and whose solutions have become so standard that that is now the starting point now. We do not start from scratch in 2023. We need to understand how to do it, but actual training thing we do not start from scratch. The data set which is most common in this computer vision is ImageNet. You should look at it. It has one really amazing research paper, and I really recommend you read it. So this was to 2014, and then there is another one on their results. So if you go to their website and home, I think somewhere they have a detailed write-up of the latest changes they have made. It is a very nice paper. Just I'll maybe upload the link when I find it. So that is the standard one, ImageNet for images, where it has, see, 14 million images and constantly new ones are getting added. Okay. So standard data set and its standard solution. One of the standard solutions is efficient net. So going back to this code, the code is the same as above, 240 neurons, 120 neurons, but based on top of a pre-trained model. This model was trained on general data of this ImageNet. It has 1000 different classes in everyday objects. And whatever knowledge it has, we start from that pre-trained model knowledge as is. And then on top of that, we make it, we use it as is. That's why we said, I don't want this to be trained. We introduce this as the beginning part, and then the rest of the neural network, same as above, we add. And we call the training function, and you will find when I run it for 5 epochs, you'll find that just in one epoch, just by going through the entire data set just once, it reaches 50% accuracy. By the end of 5 epochs, it reaches 70-75 accuracy, which is an excellent starting point. This extremely simple model, simply by adding on top of a good pre-trained model, and which solutions to kind of like check, you have this ImageNet benchmark. If you check, it starts back from 2012, where the top architecture was called as AlexNet, to now 2023. It keeps on improving, but there are around 5 to 10 standard architectures everybody uses. We just need to know them, set it up as the top of our model, and rest we just train it for this use case, and we get a good enough accuracy. So that was the second stage. After the training and everything was done, writing the model from scratch and transfer learning the model and seeing how doing this from scratch to get a 50% accuracy, you need to, write a bigger model, train it for a really long time. But a better shortcut, start from existing trained model. So this was this. And after doing all that, it is actually at the final Kaggle submission. So you are reading all the files present in test and writing them into a format, so that we read image one by one and convert it into the format this Kaggle computation needs. So it needs 17 decimal digits for probability. So I had to write this hacky code to get it into the format needed, but running this thing takes a lot of time. So I have done the end-to-end pipeline, but unfortunately, the exact precise final step of it is remains a bit slow. But even without that, everything is done from data set to model to this thing in minimum number of lines, so that code is easy to read, and then subsequently, it also means it is easy to understand and do it on your own for any other Kaggle competition. So this is how I have standardized. You can check it on GitHub, and all of these solutions, they start from papers with code, and then once we get good enough accuracy, just upload it onto TensorBoard or weights and biases. That is the industry standard where we can include this report, and then we are done. Just upload it and get a rank on Kaggle. This is how the process is.